Welcome to MarkScheme, solving quadratics and the discriminant. Everything you need made visual. Throw a ball, model a profit, trace an arch, a parabola. And one question keeps coming back. How many times does it hit the ground? Where does the curve cross this line? Y equals 0. The answer is always the same. 3 choices. Twice, once, or not at all. Green crosses twice. 2 solutions. Gold just kisses the line and turns away. A single repeated solution. Rose floats clear above and never lands. No real solutions at all. Here's the magic of this topic. You can tell which of these you've got before you solve anything. From one small number. That number is the discriminant. Here's exactly what this covers, straight from your syllabus. Analysis and approaches, standard level 2.7. Solving quadratic equations, by factoring, and by the quadratic formula, which will actually derive, not just quote. The discriminant, delta equals b squared minus 4ac. What it tells you about the nature of the roots, 2, 1, or none. And solving quadratic inequalities. This sits on top of the quadratic function, 2.6. If completing the square is rusty, watch that first. We build the formula straight out of it. Let me show you that number in action. Here's the simplest possible family. Y equals x squared plus c. It's a parabola. We slide straight up and down by changing c. For this one, a is 1, b is 0. C is C. So the discriminant, b squared minus 4ac, is just minus 4c. Watch what it does. Right now, c is negative 3. The curve dips below the axis, and it crosses twice. Now I lift the parabola. As c climbs toward 0, delta, which is minus 4c, falls toward 0. And watch the 2 crossings slide together. They're closing in, and at c equals 0, they merge into 1. Delta is exactly 0. The parabola no longer crosses the axis. It just touches it. A single tangent kiss at the origin. That's the knife edge. 2 roots have become one repeated root. Push c positive, and the whole parabola lifts clear of the axis. Delta goes negative, the curve floats above the line, and never lands. No real roots at all. So the sign of one little number, delta, tells you the entire story. Positive means 2, 0 means 1, negative means none. Let's earn that formula, then use it everywhere. You already know factoring. X squared minus 5, x plus 6 splits into x minus 2, x minus 3. So x is 2 or 3. Set each bracket to 0. If a product is 0, one factor must be. Fast when it works. But change one number. X squared minus 5, x plus 3. And nothing factors nicely. We need a tool that cracks every quadratic. So let's build one. By completing the square on the general form. Start from x squared plus bx plus c equals 0. Divide through by a, so the leading coefficient is 1. Now complete the square. Halve the x coefficient. b over 2a, square it, and subtract the extra bit. Tidy the right-hand side over a common denominator. And look what appears on top. b squared minus 4ac. Take the square root of both sides. And this is where the plus or minus is born, because a square root has 2 signs. Subtract b over 2a, combine over the same denominator, and there it is. X equals minus b, plus or minus the square root of b squared minus 4ac, all over 2a. The quadratic formula. It's on your formula sheet, But now you know exactly where it comes from, and where that b squared minus 4ac under the root came from. Look hard at the formula. Everything about how many roots you get is controlled by the piece under the square root, b squared minus 4ac. We give it its own name, the discriminant capital delta, because it discriminates between the three cases. And you never have to fully solve to know which case you're in. If delta is positive, the root is a real non-zero number. The plus or minus gives two different answers, two distinct real roots. The curve crosses twice. If delta is exactly 0, the square root is 0. Plus 0 and minus 0 are the same. One repeated root. The tangent kiss. And if delta is negative, you'd need the square root of a negative number, which isn't real, so there are no real roots. The parabola misses the axis entirely. 3 cases, 1 number. Now inequalities. And the trick is to stop thinking algebra and start thinking picture. Take x squared minus x minus 6 greater than 0. First factor it exactly as if it equaled 0. X minus 3, x plus 2. So the parabola cuts the axis at x equals minus 2 and x equals 3. Sketch it. It opens upward because the x squared coefficient is positive. Now just read the sign off the graph. Greater than 0 means above the x-axis. The parabola is above the axis on the two outside arms, to the left of minus 2 and to the right of 3. Between the roots, it dips below, so that's where it's negative. So the solution is x less than minus 2, OIR, x greater than 3. Notice, for greater than we get the outside. If it had been less than 0, we'd take the inside, between the roots. The sketch makes it obvious which. No sign tables, no memorizing. Let's build a ladder of examples. Easy to hard, all my own numbers, IB style. Example 1. Solve x squared minus 5, x plus 6 equals 0. This one factors, so start there. I need two numbers that multiply to plus 6 and add to minus 5. That's minus 2 and minus 3. So it factors as x minus 2 times x minus 3. A product is 0 only if one of the factors is 0. So x is 2 or x is 3. Done. And here's a good habit. Confirm with the discriminant. b squared minus 4, ac is 25 minus 24 equals 1. Positive. So two distinct real roots. Exactly what we found. The formula would give the same two answers. Factoring was just faster. Example 2 shows off the real power, describing the roots without solving. On the left, 2x squared plus 3, x plus 5. Just compute delta. 3 squared minus 4 times 2 times 5. That's 9 minus 40, which is minus 31. Negative. So with no solving at all, we know. No real roots. This parabola never touches the axis. On the right, x squared minus 4, x plus 4. Delta is minus 4 squared. Minus 4 times 1 times 4. 16 minus 16, exactly 0. So this one has one repeated root. It factors as x minus 2, all squared, touching the axis at x equals 2. One number told us the whole shape of the answer. That's what the discriminant is for. Checking the nature of the roots before you commit to solving. Example 3. The type examiners love. Work in the discriminant backwards. Find the values of k so that x squared plus kx plus 9 has equal roots. The magic trigger phrase is equal roots. That is the same as saying the discriminant is 0. Whenever you read equal roots or a repeated root, or the line is a tangent. Immediately write delta equals 0. Read off the coefficients. A is 1, B is k, C is 9. So delta is k squared minus 4 times 1 times 9, which is k squared minus 36. Set it to 0. K squared equals 36. Now take the square root of both sides. And don't drop the plus or minus. K is 6 or minus 6. Both work. Each makes the parabola sit perfectly tangent to the x-axis. 2 answers. And dropping 1 is the classic way to lose a mark here. Example 4. A full inequality with a leading coefficient and a less than or equal sign. Solve 2x squared plus x minus 6 less than or equal to 0. Same plan. First, solve the equation. It factors as 2x minus 3 times x plus 2, giving x equals 3 halves or x equals minus 2. Those are where the parabola meets the axis. It opens upward, so it dips below the axis between the roots. We want less than or equal to 0. Below the axis plus the roots themselves, where it equals 0. That's the stretch between the roots, endpoints included. So the answer is minus 2, less than or equal to x, less than or equal to 3 halves. Because the sign is less than this time, we take the inside. And because it's an equal to, the endpoints are in. So we use closed inequalities. Example 5. The hardest, blending the two ideas. A find k question that ends in an inequality. For which k does x squared plus kx plus 4 have no real roots. Trigger phrase no real roots means the discriminant is strictly less than 0. So this time we don't set delta to 0. We make it negative. Delta is k squared minus 4 times 1 times 4, which is k squared minus 16. Set that less than 0. K squared is less than 16. Careful here. This is itself a little quadratic inequality in k. K squared less than 16 means the size of k is less than 4, which is the band minus 4, less than k, less than 4. So for any k strictly between minus 4 and 4, the parabola floats clear of the axis. Notice the whole topic came full circle. We solved quadratic inequality to finish a discriminant question. Now the exam craft, other channels skip. 1. Check the discriminant first. A 10-second delta calculation tells you whether to expect 2 roots, 1, or none. So you never waste time solving something with no real answers. 2. Learn the trigger phrases that secretly mean delta equals 0, equal roots, a repeated root, just touches, is a tangent. Every one of those is a find k question wearing a disguise. 3. For inequalities, never memorize sign tables. Factor, sketch the parabola, and read it. Greater than 0 is outside the roots. Less than 0 is between them. And 4. On paper 2, your calculator's equation solver hands you the roots in one tap. But if the question says find k, or hence, you must still show the discriminant or the factors on paper, because those method marks are where the marks actually live. Finally, the 4 traps. 1. Dropping the plus or minus. X squared equals 16 has 2 answers, 4 and minus 4. And that same slip word loses a whole solution in find k questions. 2. Sign errors in delta. If b is minus 5, b squared is plus 25. Never minus 25. Square first, then worry about signs. 3. The inequality direction. Greater than 0 is the outside arms, not the inside. Always let the sketch decide. And 4. Confusing the discriminant with the roots. Delta doesn't give you an x value. It only tells you how many there are. dodge these. And 2.7 is free marks. And that's SL 2.7, fully covered. Solving quadratics by factoring. And by the formula we derived. The discriminant b squared minus 4ac, and exactly what it tells you about the roots. And quadratic inequalities read straight off the parabola. Next in the course, we divide by x and watch curves race toward their asymptotes, reciprocal and rational functions. For more, that's markscheme.app. See you there.